Next up in this series, we are going to tackle infix expressions. Let's use one of these to act as a guide as we build out a data structure in our AST package to represent this in our abstract syntax tree. We have an expression on the left side that will evaluate to a value. We have an expression on the right side that will evaluate to a value. We have an operator that we will apply to both sides that we can represent as a string. And we are also going to store the token associated with our operator as well. Of course, we are going to override the expression node marker method, and the token lexeme will return the lexeme of the token. Now going back to our parser file, in our parse expression method, we only have the capability to parse prefix expressions. In order to parse these infix expressions, the first thing that we need to do is associate tokens with a corresponding precedence level. We defined these precedence levels in the previous video. Next up, in the constructor, we need to create a map that is going to connect these tokens with a particular function, like we did with the prefix function. Now we actually need to code the parse infix expression method. The first thing that we do is create our infix expression object. The current token in our parser holds the operator we are working with, like multiplication or addition, so we will use that as our token, and its lexeme is our operator. The left side of the expression is passed into this method as an argument. We then call a helper method to call the current precedence that just retrieves the current token's precedence. It looks like this. Returning to our parse infix expression method, we then call getToken to advance our parser. We then finish by calling parse expression again, this time passing in the precedence we just received. Then we return the expression. As our second to last step, we will register this expression with the different tokens in our constructor like we did with the prefix expressions. And the last thing to do is to finish our parse expression method that we started in the last video. Finish it by adding the following. After we call our prefix expression to retrieve the left side of an expression, we then enter this for loop that contains all the magic of prat parsing. And you can see that we are using the precedence that we passed in as an argument. It flawlessly parses the elements that need to be executed first. And we are going to walk through this in depth in the next video. If you want to get a head start, I highly encourage you to pull out a piece of paper and walk through the code we have written thus far with an expression like this. Until then, deuces.